Select the major products of the following reaction. So if we look at the starting material, we see that we are starting with an ether, which are generally not very reactive. We use ethers for solvents a lot, in fact, because they are so unreactive in most circumstances. In the presence, though, of a strong acid like HBr and heat, we can force an ether to undergo a substitution reaction. And the substitution reaction is actually going to cleave the ether, so we call this an acidic ether cleavage. And this reaction can take place by either substitution mechanism. So this can either be an SN1 or an SN2 substitution, and it depends on the ether structure. So the same sort of trends we saw for other SN1 and SN2, where we'd see a tertiary ether undergoing SN1, and something that is SN2 would be more likely to be a primary or secondary ether. And so if we look at the one that we are starting with here, we have a primary carbon on one side, and on the other side we have an sp2 hybridized carbon of a benzene ring. And so we cannot do substitution by SN1 or SN2 pathways on a benzene ring. So we're not going to be doing our reaction here. We're likely going to be having a substitution occurring at this primary center. So the first thing that will happen is your ether can act as a base and be protonated by the strong acid, the HBr. So this ether will grab the hydrogen from the HBr, and we're going to break that hydrogen-bromine bond, and this is going to give us bromide as the nucleophile that can undergo this substitution reaction. So we can draw the product of this protonation, and what we've done is analogous to what we saw with alcohols, in that protonating the oxygen is going to transform a poor leaving group into a good leaving group, because now it's protonated, and when it leaves, it can leave as a neutral alcohol. And so we've generated the bromide ion as well, and this is the nucleophile. And since the center where we're doing the reaction is primary, we're going to be looking at an SN2 substitution, which means it's going to be concerted. So your bromide is going to attack that primary carbon and break the bond between the carbon and the oxygen. So this is going to form an alcohol here. So we will have phenol, which, because of that being an sp2 center, it cannot undergo any further reactions. And we will have generated this 3 carbon atom chain with a bromine, so one propyl, or one bromopropane. And so these are the products shown in option D.